You're holding a small piece of gold in your hand. It's heavy, warm in color, almost timeless. It sits on rings, crowns, circuit boards, and inside bank vaults. For thousands of years, humans have fought wars over it, crossed oceans for it, and built entire economies around it. But here's the strange part. That gold was never supposed to be here. So where did it really come from? Before we go any further, make sure you're subscribed and leave a like, because the truth behind everyday things is often far more incredible than we realize. Most people assume gold formed deep inside the earth, maybe squeezed under pressure, maybe cooked by volcanic heat. That sounds reasonable, right? After all, diamonds form under pressure, oil forms underground, so gold must be just another earth-made material. But here's the truth that surprises almost everyone. Earth can't actually make gold. To understand why, you have to go back, not thousands of years, not millions, but billions, back to when the universe itself was young. Right after the Big Bang, the universe was mostly hydrogen and helium. That's it. No iron, no silver, no gold. Just the simplest elements. Over time, gravity pulled clouds of gas together, forming the first stars. Inside those stars, nuclear fusion began. Hydrogen fused into helium, helium fused into heavier elements like carbon and oxygen. In massive stars, fusion continued all the way up to iron. But iron is where things hit a wall. Creating elements heavier than iron, like gold, requires more energy than a normal star can produce. A regular stellar life cycle simply doesn't have the power, so gold cannot be made in ordinary stars. This is where most people get confused. If stars can't make gold, then what can? The answer is violent, catastrophic, almost unimaginable. For a long time, scientists believed gold was created during supernova explosions, the massive death of giant stars. And supernova are powerful. For a brief moment, they outshine entire galaxies. But recent discoveries revealed something even more extreme. In 2017, astronomers observed a collision between two neutron stars. These are the ultra-dense cores left behind after massive stars explode. A single teaspoon of neutron star material would weigh billions of tons. Now picture two of them spiraling toward each other at incredible speed. When they collide, they unleash more energy in a fraction of a second than our sun will produce in its entire lifetime. In that explosion, called a kilonova, the conditions are perfect for forging heavy elements: gold, platinum, uranium, elements too heavy for normal stars. And here's the staggering part. Scientists estimate that one single neutron star collision can create more gold than the mass of our entire planet. Let that sink in. The gold in your jewelry, in your phone, in ancient artifacts was likely born in one of the most violent cosmic events imaginable. But how did it get here? After those collisions, the newly formed elements were blasted across space as dust and debris. Over millions of years, that material mixed into vast molecular clouds. Eventually, one of those clouds collapsed and formed our solar system. The sun ignited, planets began to form from the leftover material, and mixed within that spinning disk of dust and rock was gold. So Earth didn't create gold, it inherited it. There's another twist. When Earth first formed, it was molten, a massive ocean of magma. Heavy elements like gold should have sunk deep into the planet's core, and much of it did. In fact, there's likely far more gold locked inside Earth's core than in all known mines combined. So why is any gold accessible near the surface at all? Because after Earth cooled and formed a crust, it was bombarded by asteroids. These space rocks carried additional heavy elements, including gold, and deposited them into the outer layers of the planet. Much of the gold we mine today may have arrived after Earth itself was already formed. Here's what surprises most people. The gold around us is older than Earth, older than the sun.
It's cosmic debris from an ancient stellar collision that happened long before our planet even existed. When you see gold, you're not just looking at a precious metal, you're looking at the ashes of dead stars and the aftermath of cosmic violence. You're holding a piece of an event that occurred billions of years ago, light years away, in a universe that was still young. And suddenly, gold feels different. It's not valuable just because it's rare, it's valuable because it's extraordinary. Its journey spans exploding stars, neutron star collisions, interstellar dust clouds, asteroid impacts, and the formation of our planet. The next time you see a gold ring or a small gold coin, remember this. It was forged in chaos, traveled across space for millions of years, survived planetary formation, and ended up in human hands. That tiny object carries a story older than anything on Earth. And maybe that changes how you see it, because sometimes the simplest things hide the most misunderstood truths.